is not going to be until probably Friday, which is when I originally wanted to test. Hey, guys, if I'm talking, I need you to pause. KB, eyes and ears here, okay? There's two things you're going to have to be able to do on that DYU. The first is you're going to have to be able to construct the table and the graph for parent functions. And I'm not telling you which parent functions I'm going to give you. You have to know how to do that. And the reality is, I've told you before, Walter, eyes and ears here, please. I've told you before, I'm not going to memorize my tables and graphs. I need to know what the general shape is of the graph, but how did we eventually start creating the table? Because we got to be able to do this faster. Well, actually, let me ask a different question first. Normally, what's a good input to have in the middle of my table? 0. Usually, we want 0 in the middle. And then we may just go by 1s around it. Not always, but we go by 1s around it. Why did we not have 0 in the middle of this table?
Can't square root a negative.
So remember, we can't take the square root of a negative. The square root function is one of the special ones where we got to remember we're not taking square roots of negatives. Again, I will put the caveat of yet, but we can take the square root of 0. Remember, when we have our inputs for the square root function, what type of inputs do we want? I heard a couple of groups talking about it. I heard the aces, I heard queens, or I talked to the queens about it for sure. Not just positive, there's something else about those inputs that we want.
They're
perfect.
Remember, we're taking a square root, so we need a perfect square. Right? So when I say a perfect square, what I'm talking about is, what is 0 squared?
0.
What is 1 squared?
1.
What is 2 squared? These are my perfect squares on the right-hand side. Those are the inputs I'm going to want to use with a square root function. We need to be able to quickly identify that. I got a square root function. I need my perfect squares. 1, 4, 9. And then, guys, again, take the time to use your function notation. Even just 1 or 2 times writing this out is going to help you think through. So when I say the square root of 0, what is the square root of 0?
0.
0, right? What was squared to get a 0? Oh, 0 was squared. So input of 0 has an output of 0. I'm going to jump to f of 4. Square root of 4. Notice I'm just putting inputs in, and then I'm going to get an output out. What was the square root of 4? 2. Right? We're just taking the square root, and so I'm showing that using my function notation. 0, 0, 1, 1, 4, 2, 9, 3, 16, 4. Make sure when you create a graph that you use an additive scale. What I mean by that is constantly adding to create the scale. Don't jump from one number to the next. Be careful when creating a graph. Aces, does anyone see what I would want to push on with their graph that we need to be careful about?
arrows going down.
Yeah, notice at the end there that arrow starts to dip down. But what did we talk about? This is going to keep going to the right and going up. I understand. I just want to make sure we're learning from these mistakes. Guys, I need to revisit something, and I hate that I haven't said this in a while, but I'm very frustrated with this class in particular about a couple of things. First things first, mistakes are not a bad thing. Doing nothing, that's a bad thing. Doing nothing is not going to help you learn. But we investigate our mistakes. We learn from our mistakes, right? Miss Frizzle with her Magic School Bus. It's goofy, but it's true, right? We need to take chances. We need to make mistakes and get messy. Like, the way that we learn is by taking risks. And the next part is we've got to actually talk about the math. I don't care if you like the person in the group the people in your group. I don't care if you've never talked to that person in your life. Like, at the end of the day, you're going to live a life where you have to meet new people. You're going to have to collaborate with new people and work with new people at jobs. Like, point blank period, I know some of you have jobs where you got people at work that you don't particularly like. Okay? Now, are you allowed to just not talk to them at all? Or do you have to work with them? You got to work with them. So, get over yourselves and let's actually, talk to people, even if we don't particularly love them. The other thing is this: I need you to understand that if you talk to somebody about what's happening, everybody wins. If you are struggling and you talk a detail out, talk an idea out with your group members, then that talking process is going to force you to think. And you know what thinking helps you do?
Learn.
It helps you learn. Point blank period. I don't care if you like talking to them or not. Talk and you will learn. Okay? Second, if you are the person where you're like, man, I'm crushing this. I know what I'm doing. I know that Dean knows what he's doing. I know that Rihanna knows what she's doing most of the time, right? I just say most of the time because she gets a little upsetty with me sometimes and doesn't like to talk. But like when you talk it out, like I can hear you talk it out. But on top of the fact, like if you are explaining it to somebody else, then you're going to learn it better as well. If you talk, everybody wins. If you talk, everybody wins. And at the end of the day, you are going to be personally responsible for learning this. I don't put the pressure on you in the middle of class of collecting your group work to create a grade. It's just your active collaboration score. But at the end of the day, you're going to have a DYU, you're going to have a test, you're going to have a proficiency scale where you have to show the evidence that you understand. So yeah, you might be able to hide in class a little bit and not talk. But if you're not talking and you're not learning and you're not growing, you're not going to do well on the DYUs. You're not going to do well on the assessments. There are students right now, and I understand like it's easy to be like, oh, well, they know what they're doing, so it's easier for them to talk. But there are students right now who are talking more last unit and this unit than they did in the first unit, and they're doing better than they were originally. Because when you talk it out, you learn about stuff. When you talk it out, I can hear where you have misconceptions, so I can help you learn out of it. So let's talk. Let's talk about the math. Because my class is not one where you're going to be able to cheat your way through by copying someone else's work or doing that for assessments. Like, that's not going to happen in here. But if you talk it out, you're going to learn something. I need you to trust the process. Been doing it for over a decade at this point. And I don't teach today like I did 10 years ago because I've learned and learned and learned. I've taken chances. I've gotten messy with my teaching because I've made mistakes, and I've learned from those mistakes. And the students who have trusted me have learned more in this class than they did in the other classes. And at the end of the day, learning is social, and learning can be fun when we talk things out. It is frustrating, and it pisses us off when we're sitting there and confused. You got 3 heads. Put them together, talk it out, learn together. I need y'all to understand, I'm bringing this up because, yeah, I'm frustrated and I'm honestly a little pissed off because I see us not being successful because we're not doing the things that I asked. You're capable of amazing things. If I didn't think you were capable of thinking and capable of learning that way, then I would stand at the front of the room, I would do a direct lecture, and then just go have you practice it 30 times. But you're better than a robot that just has to be told exactly what to do. You're capable of thinking and learning. And I told y'all from the beginning, I'm going to present a problem to you. I'm going to ask you to think, come up with conjectures, take chances, get messy, and make mistakes. And then I'm going to talk about it afterwards. And when I talk about it afterwards, that's when you're going to get a chance to take notes. And then you're going to apply it and practice with it. But you actually have to engage in the small group to be prepared to talk in the whole class discussion. And then you need to engage in the whole class discussion to be able to effectively take notes, do practice, and things like that. So as we move through the rest of today, and the rest of this week, and the rest of this 9 weeks, and the rest of this semester, I need you to engage in your small group. I need you to talk with people about the math. I need you to problem solve. I need you to take chances. I need you to make mistakes. And if you do that, you're going to grow and learn. And I don't want to hear witching and complaining about grades when we're not doing what we need to do. Now, I'll go ahead and tell you I need to update grades, but I'll give you feedback right away so that you can improve before the next assessment. I need to update grades. That's my goal for today, right? Today after class. Okay?
That's what I was going to ask. If you graded the test.
No, I've not even come close to finishing grading the test, okay? I will get to the test, but here's the thing. The reason why I haven't gotten to that is because I focus on the DYUs and the other feedback because that's going to help you prepare for the test. The test is the summative grade. It's the end. That unit's over. And there's some things that are going to apply to this unit, but the test is a lower priority. Even though it's a higher point value, it's still only 20% of your overall grade. So it's not a priority for me. And Walter still needs to take his test. When are you going to make up your test? Well, talk to me after this. All right, so parent functions. Guys, you're going to have to construct your own parent functions. You got to know what are good inputs and outputs. And for the most part, -2 to 2 are a good set of inputs, having 0 in the middle. You have to remember, with a square root function, you need your perfect squares. With a cube root function, what inputs do you need?
Cube.
The perfect
Square.
cubes. For a square root function, we need perfect cubes.
You don't need those things.
Alright, so we're going to, so we did that parent functions recap. At this point, we have transformations, and we're going to finalize some details from yesterday, and then get a little bit deeper into these ideas. So first things first, so generalized transformations, understanding them, but then how it directly, specifically affects things. So yesterday, what was the conjecture, so I'm skipping that, what was the conjecture about translations? Well, when we look at the absolute value of, so A times the absolute value of x minus h plus k.
A.
Oh, it had addition and addition and subtraction.
Okay, so addition, subtraction, hold on to that. So which letters were translating our functions?
H and K.
Okay, so h translated the parent function. Did we have anything more specific with that h translating the parent function?
Absolutely. Horizontal.
So remember how we said h was translating it horizontally. And so what did k do?
Vertical.
Translated parent function vertically. Now, I want to bring up what Rihanna talked about, because this is actually really important. We can get super focused and drawn into just focusing on h and k, but we can move these things around. Rihanna, what did you point out is actually the key detail about causing a translation?
The A and subtraction.
The addition and subtraction, yeah.
Plus and minus.
Be careful, because yeah, adding and subtracting. Yeah, that's fine. I was just going to caution about positives versus negatives, but that's not what you said. So guys, why is it the h and k? Because what are we doing?
Subtract.
Subtracting and adding. Now, I do want to point out, we're going to get into details about how much it translates by, but can anyone look right here and tell me why in the world does it make sense that h is translating the parent function horizontally? Why is h doing it horizontally?
It's the absolute value.
Not just because it's the absolute value, because it was the same thing. Say that again.
It's changing the x.
Yeah, it was changing the x. So hold on one second. Hold on to the idea. Because remember right here, Finney, we also looked at x minus h squared plus k, right?
Yeah.
And so it's not just the absolute value, but where is that h? What is the h with? It's with the
X.
x. And x, is that a horizontal direction or a vertical direction?
Horizontal.
It's horizontal, right? We need to recognize that x is horizontal. So what are we doing? We're translating the x values. That's a horizontal translation. And so we're going to talk more about that later. So why is this horizontal? Because h is with the x. K, and also I will point out, and I want y'all to pay attention to this, that means it's where, so what was the defining operation in the absolute value of x? What was the defining operation for the absolute value function? Did an absolute value define an absolute value function? What was the defining operation for a quadratic? The square. Please notice that h that is with the x, is it inside of the main operation or is it outside the main operation? It's on the inside. What about this h? It's on the inside. So h is with the x inside the main operation. I'm going to say defining operation, right? By the way, if you ever see me write fxn, has anyone picked up what that means?
Function notation.
Not function notation, it's just a shorthand for the first half of that. Function. That's a shorthand for function. fxn is shorthand for function. Okay, k then, translating parent function vertically, notice k is what?
On the outside.
Is outside defining function operation. So we're going to come back to this a little bit later, but guys, I need you to take some of these notes, right? Remember, I asked y'all to just make conjectures yesterday, to develop conjectures. I'm finalizing, firming up these details right now. You need to have these notes. We're going to talk more about this with some details later, but you need to have those notes for sure under translation. Okay, first off, listen guys, if we're saying, so some of us are saying other things, but x minus h squared, first off, what is the square? That is my, doesn't that square define the operation?
Yep.
Okay, so that's not a transformation. What defines this function?
Absolute value.
Absolute value. So that's not a transformation. We've already talked about the h and k are what?
Translation.
Those are the translations. The addition and subtraction is the translation. Where do we see multiplication? A is the only thing left, right? We're multiplying.
Okay,
Right?
I get that.
And then A is multiplying. So that A is my multiplication. And what did we say yesterday A was doing?
It's dilation.
It's a dilation
And reflection.
and a reflection. Now, I would at least make the note under, and have that note, that the reflection is coming from A and the dilation is coming from A, but we have to know when is it a reflection and when is it a dilation. And that's what we're about to explore. Okay, so we know that A is creating a dilation, A also can create a reflection, and we need to know when that is the case. So we're going to explore this more heavily in the Desmos activity.
You said A creates a dilation?
A is creating a dilation and and it can create a reflection.
Huh? Like, reflection, or do you put A?
So under the
create a reflection.
under reflection, just at least make sure you know you have an A there.
And you put the same thing for dilation. Just put A create a dilation.
Okay? So please pay attention to this specific set of instructions, because I constructed this intentionally. Work a little bit faster. Alright, I'm going to come back to this. Alright, so remember yesterday we got through this cubic function, and we looked at this cubic function. I'm going to zoom in just a hair before I have you go to the next piece. But when I look at this cubic, does H still horizontally translate?
Yep.
Yes.
Yep, definitely. Okay. Does K still vertically translate?
Yep.
Yes.
See how it's moving the function up and down. Notice I can put them together. If I do H is 2 or 3, it goes to the right, and if I do K is 3, it then goes up. So you can put multiple together. It's harder to see sometimes when you have more than one. And then let's check A. Does A still dilate in some way?
Yeah.
Yeah. Stretching. And then does it cause a reflection at some point?
Yep.
Yep. Notice it is a vertical reflection. Okay, so we're going to explore this more heavily here in slide 5. So what I need you to pay attention to in slide 5 is this. By the way, Jackson, whoever was a, that's not what I wanted. Jackson, whoever was a 4, work on this board up here. But what I have done is I've intentionally gone in and put some points with what parent function is this? That's the square root function, isn't it? Square root shape?
Yeah.
And if I check it, and what's the square root of 0?
0.
Okay, that maps there. Square root of 1.
1.
And what's the square root of 4?
2.
Square root of 4 is 2, right? So notice those all map. Here's what I need us to do is I need us to figure out, first things first, how does H actually transform those individual points? So when I look at an H of 1, an H of 2, 3, 4, how is H of 4 changing those points? And what I need us to recognize is, when I look at these points, have those y values changed at all?
No.
Those y's are exactly the same.
Oh,
But have the x values changed? So the question is, how much? How is the values? How are the values changing? So we already said h is a horizontal translation. So my question is, when is it to the right? When is it to the left? And by how much? So we know that h is a horizontal translation. When is h going to create a translation to the right? When is h going to create a translation to the left? And then by how much? K. We know that's a what?
Translation.
Which type?
Vertical.
We said it was a vertical translation. So you know what questions I want you to ask and be able to answer? Make predictions? So when is it up? When is the translation down? And by how much?
We talked about this.
What do you mean by how much?
Before we did.
Well, like right here, how much did it translate to the right 5? Or how much did it translate to the right? Okay? Yeah. So think through, how are we going to be able to look at the equation and know how much it's translating to the right by, to the left by, up, down? Finally, we know that A
Is the dilation.
is a dilation and a reflection. And we know they're both vertical, right? So the question for a dilation is, when do we have a compression? Because that's one type of dilation. That's when we make something smaller. So when does the dilation have a compression? What A value has a compression? When do we have a stretch? And finally, when do we have a reflection? So you need to think through what A value translates it to the right, what translates it to the left, by how much? What values of K translate up and down, and by how much? What values of A compress or stretch or reflect? So what are the values that of H, K, and A that create these transformations? Okay? So, I don't care if you get answers wrong. Guess what? Take some chances. Get messy. Make some mistakes. What I don't want is I don't want us not talking about the math. I don't want us standing around. Because literally you have a graph here that you move sliders and all you have to do is come up with a conjecture. We're going to talk about it afterwards. Talk about the conjectures, but you got to do something. So let's get up. Let's move to our vertical surfaces. Let's take some chances. Let's get messy and let's make some mistakes. I might have an answer.
Alright, so
Come on. Not hiding our head, not putting our head down. We got to learn.
alright, so
Say again. So like the H, right? We said that H creates a horizontal translation. So when does this, what H values translates this to the right? What H values translates this to the left? Okay. What's going to what values of K translate up? What values of K translate down? Okay.
so this is dilation.
Correct. Yeah. Dilation and reflection. Okay. So let's get it going. Let's come up with conjectures. Let's move to our vertical surfaces.
You just can't let this
So, let's talk about this. Let's formalize this based on our conjectures. Now, we're also going to check our conjectures. Looking around the room, the most common things that I saw was, so we knew H is a horizontal translation. When was it translated to the right? When H was?
positive. Wait, it doesn't come out?
Yeah, H was?
Positive.
Positive. Okay. When did the function translate to the left? When H was?
Negative.
Negative, okay. And so how much did it translate to the left or to the right? So don't look at that graph over there. If I change this H to a 7, what do you expect the graph to have done? If H is 7, it's going to go to the right. 7, right? Let's look at it. 0, 0, sorry, I'm going to have to erase this. 0, 0 became what? 0, 0 is now
7.
7, 0. So, notice I'm going to make a table real quick. Here's my parent function. Now, what I have is 7, 0, 8, 1, and 11, 2. Look at the table. What do you notice has changed about that table?
All the X values.
Oh, what about the x values? The x values of what?
It changed.
But how much have they changed by?
However much you want to change, Mr. Kennedy.
Not how much it wants to change. It changed by what? 7. We added 7. We added 7. We added 7. Why is it adding 7? Because h is 7. Okay? We need to recognize that. Let's look at, don't look at the graph, just look at h right here. If I make h a -4, what do we expect to happen to our function?
It changed by -4.
Translated to the left, how much?
-4.
You don't have to say -4. If you say left, it's just left 4. It's already negative by saying left.
Oh,
Does that make sense? Okay, let's check. It is now -4, 0. It's -3, 1. And 0, 2. Look at those points. Did it translate to the left 4?
Yep.
Did we subtract 4 from everything? Yeah. Because we need to recognize whatever, how much is it translating? It's however much.
The K value.
Well, remember, we're still looking at
The value.
h for horizontal.
I mean not K, I'm sorry.
How much does it translate? By however much h is. Making conjectures off of that, we need to recognize it's okay. And so like over here, this group said k, each point goes up by 10 when it moves up, right? But what value would k need to be for each point to go up by 10? But what would the value for k be?
Anything we put it in?
So, yeah, it's like if we say each point goes up by 10, as the Kings did, what does k have to be? Plus 10, or a positive 10, right? Okay, so let's put h back to 0. Let's say k is 3. What do we expect to have happened? It goes up 3. Now, let's look at the tabular version of this. I'm going to move this out of the way. So, looking at the table, we now have 0, 3. We have 1, 4. And we have 4, 5. Notice, did my x values change at all this time? No, because what direction did we translate?
The Y.
Up, so vertically, which is the what?
The Y.
We need to recognize a vertical translation is only changing the y. Specifically, how much did each y value change by? No. Because it went from 0 to 3, didn't it?
3.
So it went up how much? 3. Up.
3.
3. Up.
3.
Why does that make sense? Because what was k?
3.
3. So when is that function translating up? When k is? No.
Well, what is K is?
K
Positive.
positive. K is positive. When is it down?
Negative.
What is it? When k is negative. Walter, can you move that k to a -6? When he moves k to a -6, how far do we expect it to translate down?
-6.
Down 6?
Or down 6.
Let's look at it. 0, 0 went 1, 2, 3, 4, 5, 6 down. Notice I can see it graphically going down 6. I can see it tabularly because it went to 0, -6.
What? Well, hold on. Tablet. What that mean?
Table, my guy. We've only been doing this since the beginning of last unit, right?
I
We've been doing it for like 5 weeks now, right? Like, come on.
Ooh.
So we got graphically and tabularly, right? We good, Vinny? Okay. All right, so k is negative. By how much? However much?
Value K is.
Whatever k is.
How much K is.
However much k is. Whatever the value of k is. In this case, it's down 6. But in general, it's whatever k is, that's how much it translates up or down. Now, I'm going to take a second, and I need to point this out. And we're going to get practice with it, but I need you to see this. Let's say I gave you this function right here. Notice, I don't just have one translation. How many translations do I have?
2.
2. One of them is going to be horizontal and one of them is going to be vertical. You don't have to graph it, but what I want you to do is I want you to come up with a conjecture about how much is it this translated and in what direction. So go to your vertical surfaces. Here, we're going to look at this in a second, but I need you to come up with how much is this translated left, right, up, down. Come up with a conjecture for it. 3, 2, 1, go.
Right, up, down.
And by the way, not left and right. Like, is it left? Is it right? Is it up? Is it down? By how much? So just write a description and come up with a conjecture, which is great. All right, we have to learn from this mistake, though. So, hey, ladies and gents, Malia, pause for a second. Right here, I need y'all to look at this. What we made is the most common mistake, and I need y'all to look. Hey, eyes and ears. Eyes and ears.
I'm listening, sir.
Okay. Right here, I need us to look at this point. I'm going to make a table of this in a second. Actually, I'm going to put it right here. So what was my parent function? The square root of x, what were the points? 0,
What did you say?
0, parent function 0,
1,
0,
1,
1, 1.
1,
What's real like?
1, 4, Okay.
Get closer to the action.
I'm gonna say get closer, but you just came from right there back there.
Cause I got 20/20 vision.
I got 2025.
I got 225.
It's not a such thing as 2025.
I know.
We need to listen to Mr. Kenny.
1, if any there is, 2,
Exactly.
I ain't been a long time.
I need y'all to focus. I need you to actually try to learn something. So, right here, look at this function again. You can't actually see it right now, hold on. All I did was I typed in that equation, square root of x plus 3 minus 4. It's right here. Notice, does this point go down?
Yes.
To get over to here, did it have to go down?
Yep.
How far did it go down? 1, 2, 3, 4. Went down 4, right?
3.
But you all thought it was to the
Left. Right.
You all said to the right 3. What did it actually do?
Left. I meant left 3.
Interesting.
Why is it negative?
Well, how is it to the left 3 though?
Right here, remember, and this is what, so I did all this so that we can update our translation notes and add some information in a second, and I would put this example in there. Remember how it was a or times the square root of x minus h plus k? Right now, what we have is the square root of x plus 3 minus 4. To go from a negative to a positive, what did I have to subtract? What did h have to be?
Positive.
If I put a positive 3 in here, I'm left with x minus 3.
H had to be H. 1 times 1 basically. I'm guessing. Oh no. I don't know.
Guys, right here, no, not 0. What do I need to subtract so that I get x plus 3?
1.
Oh, Jesus.
0.
Negative 3.
Thank you, negative 3.
Not lying.
Hey guys, how do we go from a subtracting to adding? When we subtract a negative. H is a negative 3. I need y'all to hold on to this. If H is positive, it is to the right. If H is negative, it's to the left. I intentionally did not say add or subtract. Because what are we doing right here? We are subtracting. And if you subtract a positive, right? If I subtract a positive 3, this H is 3. That would be to the right. When it's a plus here, the only way we got to a plus was by subtracting a negative. So H had to be negative 3. What I need y'all to hold on to and pay attention to out of this is there's 2 ways to understand this. You can actually understand that to get x plus 3, we're subtracting a negative 3, so h had to be negative 3. Like, you can do that. Or, you can pay attention to the fact that with the h, you need the opposite sign. I need y'all to hear that again. With the h, you will need the opposite sign. Because to subtract by a negative is the only way to get plus. So h is actually a negative 3 here. If I had given you the square root of x minus 7, x minus 7 would make it go to the...
X plus 7.
Well, not x plus 7. It is x minus 7. But the h, is it a positive or negative 7? Positive. Remember, I just said you will need the opposite. for the horizontal only. Notice the K did actually go down 4, didn't it? Okay? So when it comes to the horizontal, when it comes to the X, and I can go into more about it with you and explain why later, but I need y'all to understand right here and right now, everything horizontal, it's going to be the opposite of the way it appears. So because it was plus, because it was adding with horizontal, it actually went to the left. Because of this subtracting. Notice that's literally the opposite. When it comes to the horizontal, you see how we have that opposite, the subtraction right here? So whatever we get here, we need the opposite.
Is that so? That's a quadratic equation. No,
No, that's square root equation. Notice, okay, so I'm going to write that over here in a second, but I also want to point out that leftmost point, yo, focus please. -4, no, -3, -4. Then -2 and -3. And the last point there is 1 and -2. So if you can't clearly see right here, 1, -2, -2, -3, and -3, -4. Literally, what happened to the X? It was, what happened to my X every time? See how I took the X values and 3 was subtracted from it?
Yeah.
Like if you just look at the points, to go from here to here, we subtract 3. Because it was translated to the left 3. What's happening to my Y values?
Nigga, stop saying that thing.
Because what was K?
Stop lying.
Nigga, I didn't mean to say that, man.
Job. I
Okay.
feel like I'm teaching. And I'm trying to get you to learn something, but I'm definitely teaching. I need you to learn it. Notice what happened to my Y values. We just subtracted 4. So whatever H and K are, that's how much you're translating horizontally or vertically, changing the X or the Y. Now, if I were you, I would translate using my table first and then graph it, but you can graph it straight from the graph. It just gets wonky when we start doing dilations, a little bit, okay? So I would do it from the table, but notice you need to identify what H is. And I think I should say that as well. You need to identify what H is. Not if it's subtracting or adding here, you need to figure out what H is. And H is going to be the opposite of this sign, because we're subtracting.
For sure.
So, last
Yes,
bit of
Mr.
notes
Keenan.
with translating. We need to
Yes,
note
Mr. Kenny.
that the square root of x plus 3 translates left 3 because h is -3 for x minus.
We'll get in trouble.
Where have you put that at?
On your paper.
If you don't have the space, the backside is completely blank, but all of this fits under what?
Translation.
This is all translation, so if you don't have the space,
My translation is full.
that's what I'm saying, if you don't have the space, the backside is completely blank, okay?
It's really a 2025 vision, Mr.
I
Kenny.
gotta put all that. I'm not.
Do you know what 2020 vision means?
I thought it was top quality. I thought it was the best.
You can actually have 2010, or 1020.
I got 25 here.
No, that's the same as 2020. 2020 means what someone can, the normal person, the average person can see 20 feet away,
This is not about math.
you can see 20 feet away, okay?
I came here for math.
If it's 20,
I'm
30,
talking about eyes.
right? What the average person can see 30 feet away, you have to be at 20 feet to be able to see. So 2025 would mean if someone can see it from 25 feet away, you have to be at 20 feet to be able to see it. That's literally what it means.
What is
Okay.
that? It says translate. It says translate left 3, and what does it say after?
Because
Because h is
you
-3.
ain't never had
For
somebody tell you
this.
like that.
Okay?
They put B and C together.
They
That's
know
a
B slash.
Oh,
Yeah.
That's a B/C for
That's what
because.
you're supposed to do. Why would be a BC? Well, BC, yeah, look out.
What? Victoria's Secret? Lingerie. Veronica.
I need to write these notes.
Veronica. What?
Keep it playing.
So you need to identify what H and K are, not just what, if it's adding or subtracting.
Okay.
And it is important to recognize that the horizontal is going to be the opposite of what it looks like. That is the most common thing that trips students up long term. You're going to magically remember all this? You don't need to write it down? Okay, so this all goes under translations. If you need help fitting it, you can switch to the back side. Alright, last thing that we need to talk about. Listen, the dilation. Now, the dilation part is one of the more, I won't say complicated, but it's one of the more missed details because, let me put this back in so you can really see them.
Right.
Let me go back to here, alright? If I were to change this A, first things first, when A is negative, what do we need to recognize? When A is negative, what's being done?
Dilation.
I would say that looks to me the same to me.
Reflecting.
So,
Mirror.
okay, and some of us said when A is -1, but it's not just -1. When A is -2, what is it?
Reflecting.
It's compressing.
Well, it's compressing, but like.
Well, hold on to that idea. But is it reflected?
Yes.
For every A value, we got a reflection. Now, a lot of us, I need y'all to pay attention to this, a lot of us would say that this is being compressed.
Yes.
Compressed horizontally though, right?
Yeah.
But wait,
Yeah. Yeah.
wait a second. Look again. Look at, where did it go? Where is that A located?
It's before the parentheses. That means
So, is it-
multiplication.
Not just before. Guys, I need y'all to pay attention to this. Is it inside the defining operation or is it outside?
Outside.
Hey, what did we say about outside earlier? Is that vertical or horizontal?
Horizontal.
I thought H was horizontal.
Vertical is vertical.
Oh, it is
So
vertical
if it's
because
outside the main
outside.
operation, it is vertical. Okay, so I need y'all to think about this. If that's vertical, is it compressing horizontally?
No.
No, it's got to be vertical, right? But does anyone have a rubber band in here? Like, really, I probably should. I'm sure I have some somewhere.
Here you go.
Thank you. Okay, so let's say I take this right here, and I vertically stretch it. What also happens?
It
You get
compresses.
skinny.
It looks skinny, right? But what am I actually doing? Am I pressing it in, or am I
Stretching.
vertically stretching?
No.
Vertically
I'm
stretched.
vertically stretching. I need y'all to pay attention to this. Because where a lot of students would say that this is compressing, it's not compressing at all.
It's stretched.
It's vertically stretching. It is easier to see this right here with a square root function. So I'm going to move K back to 0. Right here. Now look at A. Hey, notice, right now A is what?
2.
2. What happened to my Y values? This 1 went to 2. This 2 went to 4 because what was happening to those Y values? It was being
Stretch.
multiplied by
2.
2. It was being what?
Stretch.
Stretched. It was being dilated. It was being multiplied by 2, stretching it out. And so it is vertically stretched. Okay, tell me if it's still stretching when I look at these values. Is it still stretching? Yep. Literally right now, it's stretching by what factor? What's it multiplying by?
100.
By 3. Tell me when to stop because I get to a compression. Is it compressing yet?
No.
Is it yet?
No.
What about now?
Yeah.
Yeah. Right here. What happened to 2? 2 went to
1.
1. 1 went to 1/2 because it was being multiplied by 0.5, compressing it vertically. When does it stop compressing?
So basically, Mr. Kenny,
Hold on. When does it stop compressing? When A is
I want to run.
0, and then when A is negative, it's what?
Stretched.
It's not stretching yet. It's reflecting. Now it's reflecting and what? Stretching.
So
So,
it's multiplying by negative.
If A is any kind of negative, what's it going to do?
Reflect.
It's going to reflect. If A is negative, it is going to
Reflect.
reflect. When does it compress? When A is between what values?
0 and 1.
0 and 1. If A is between 0 and 1,
I got that right.
yeah.
Ooh, I'm on the phone. Yeah. Nobody's mad.
But I am.
Look, twin. Hey, I ain't gonna, that was a good one. That was a good one.
Okay,
That was a
stretch. So when is it stretching? If A is what? Not under. It's above 1. Now, I do want to point out, I put an absolute value here because if it's a -2, right? If it's -2, what's the absolute value of -2?
Positive.
+2. And if it's a -2, it is a reflection and it is a stretch. So if the absolute value of the number is more than 1, it's going to stretch it. If the absolute value of A is between 0 and 1, because we're multiplying, it's going to make it compress. And if A is negative, it's going to reflect. That A does a lot of things all at once. Okay? That A does a lot of things all at once. And I do want to put one final note on here. This is all in which direction? Horizontal or vertical?
Horizontal.
How should we know it's going to be,
6, 7.
why should we know it's going to be vertical? Because it is, where's that A located?
Defining operation.
Right, that's all vertical because A is outside the defining operation. Now, we're going to do some more with this tomorrow and actually put these together. But these are the building blocks. If you don't have these building blocks down, it's going to be really hard to start to put everything together with this. Okay? We need to have that. Now, I do want to point out, this is where, well, let's quickly look at this. Notice what function do I have right here?
Stop doing stuff.
That is.
What's going horizontal like this? Cube root. Cube root. There's my cube root. Notice we got our points matching. First things first, if I change H.
What?
Hold on a second. Yeah, that's right. Notice if I change H, what's it doing? It's going to the right, but now when it's negative, it goes to the, and left 7, right, whatever. If I change K, it's going up.
What type of equation?
Right
What
here.
type of pair function is this?
That was a cube root. Notice if K is 4, it goes up 4. Notice, does the X change at all? No, just the Y. If you have a parent function table, you can use that to your advantage. Do notice, hey, right here. If H is -4, it went to the left 4. But I need us again to notice this. Right here, cube roots of X. If I subtract a -4, what does this become? We need to remember when it's a plus like this, the H was negative, right, Ivan? What did I say?
The H is negative.
When?
If we have the cube root.
No. When it's a plus like this, H had to be negative because we subtracted a negative. So remember, when it's horizontal, we need that to be there. Last detail. Okay? Just to see in a different one. Look at A. If A is positive, does it stretch it vertically? More than that? Yeah? I forgot to...
She said you talking about me.
Hold on.
Stop saying my name.
These notes. If A is a 0.75, did it compress or stretch? Compress. If A is a negative, what did it do? No.
it compresses too. No, it mirrors. It
reflected, and now it's also a stretch. Right. So notice these have held up for every type of parent function. And so every transformation takes the same form. Okay? Notice right here. Every parent function takes, or every transformation takes the same form. And so we're going to pick up here in slide 8 tomorrow, where we are going to practice figuring out which function is which by looking at multiple transformations at the same time. You need to have those foundations down.
What I'm gonna wear tomorrow?
You took my towel home.
I was in a